Hi Llamas, this is the first of two short videos. I'm going to show you how to use iteration to compute the largest eigenvalue or eigenvector in this case, the first thing, using matrix iteration. So the process works like this. We start with some vector and some operator, and we're just simply going to continually apply this operator t to u, and each time we do, we're going to create a new vector, and we're going to divide to keep the lengths all one. We're going to divide by the length of that vector. So we're going to iterate it some number of times. I've created a slider here that will slide up to 20 times. So we're going to go ahead and create that sequence of vectors. So the command in GeoGebra is sequence. So I'm going to use sequence expression variable start value end value. The expression I want is I want to apply the matrix k times. So apply matrix, apply matrix. The matrix is going to be t done so many times, k times, to u. And of course I don't want to forget that I have to divide by the length of this guy, so I'm going to divide by the length of that same object, apply matrix, t raised to the k, acting on u. So I want to do that, and the variable is k, and I want to do that no times up through n times. So when I execute this command, it should generate a sequence, in this case a sequence of nothing because n is 0, but as I change n, I'll get a sequence of vectors. So let's see what we get. So we get a list that just simply has the vector in it that we started with, and now watch as I use the slider. First iteration, second iteration, third, fourth, fifth, sixth. I think what you can see is I'm getting more vectors, but they're zeroing in on some direction. 9, 10, 11, 12, and now you can't even see the difference. I'm going to go up to the 20th vector, and I can't see much difference between the anything past the 10th vector. So I seem to have a direction here that points more or less in this direction, that's indicating which way the dominant eigenvector direction is. In this case, that's going to be, I think we've seen this before, x equals 2, y equals 1. So let me go ahead and plug that line in, y equals x divided by 2. And sure enough, that does seem to be the direction we're headed um, in this case. Okay, so that's the first part, how to find the eigendirection. Simply iterate the matrix operating on the vector over and over and over again, and it zeroes in. If we look at this list, you can see that the vectors are getting closer and closer to 2 to 1 x to y.